Let's see this equation. We see x appears in the denominator, in the base, and in the exponent. In the base, in the exponent. So, and the exponent on both sides of the equation are the same. So that forces the base have to be the same. So that means 3x minus 1 equals to 2x plus 6. So this is a linear equation. So we combine like terms. We move positive 2x to the other side, becomes negative. We move negative 1 to the right-hand side, become positive. So now 3x minus 2x, that's 1x. We don't need to write a 1x, but if you want to write a 1x, that's fine. And 1 plus 6, that's 7. So one solution is x equals to 7, which means 1x equals to 7. Right, we check, we see 7 plus 3, the exponent is 10. Then 3 times 7 is 21. 21 minus 1 is 20. 2 times 7, that's 14. 14 plus 6, that's 20. Okay. But is this the only solution? No, we have to consider more cases. So that's the first case. The second case, if the exponent is 0, so if x plus 3 is 0, then anything raised by 0 power will be 1. Right, so that gives us x equals to -3. -3 plus 3 is 0. 3x minus 1 raised by 0 is 1. 2x plus 6 raised by 0 is also 1. So that's the second solution. What about, is it possible to be, because we have to consider if it's a -1 raised by the same power, right? -1 raised by power, or 1 raised by power, 1 raised by any power. Well, let's see if it's possible to have the both sides to be 1. Well, it's impossible, right? Because if 3x minus 1 equals 1, that's 3x equals 2. X equals 2 over 3. But then if x equals 2 over 3, the right-hand side won't be 1. Then what about -1? -1, that means x equals 0. But -1, the right-hand side will not be 0. So we have checked, so we only have 2 solutions. All right. The first solution is because the exponent are the same, so it forces the 2 bases to be the same. So we solve, we get x equals 7. And the second one is if the exponent is 0, then anything raised by 0 power will be 0. It will be 1. So they equal to each other. Okay, so we have 2 solutions. Another way of thinking about this is we can divide both sides. Right? They won't be 0 at the same time. So let's see if x not equals to 1/3, then we can divide both sides to get this 3x minus 1 raised by x plus 3 equals to 1. Right? We can go from here. Then we consider, okay, if the exponent is 0, surely anything raised by 0 will be 1. That means x equals -3. Or if inside to be 1 or -1, let's see. 2x, so the first solution would be the same, right? Is x plus 3 is 0, then x equals -3. The second case is 2x plus 6 divided by 3x minus 1 to be +1, right? +1 raised by any power will be still 1. So in this case, we get 2x plus 6 equals to 3x minus 1, which is the first situation on the left-hand side. We solve to get x equals 7. Then we consider what if this base equals -1? Let's see if it's possible 2x plus 6 divided by 3x minus 1 to be -1. Then we have 2x plus 6 equals to -1 times 3x and -3x. -1 times -1, that's plus 1. Combine like terms, we have 2x plus 3x and 1 minus 6. So 5x equals to minus 5. That gives us x equals to -1. Let's check to see if it's possible. If x equals to -1, -1 plus 3, -1 plus 3 is 2. Right? Is 2. Then this one raised by 2. Oh, this, no, not the left-hand side, right? Yes, because the -3 raised by, that would be +1. Right? Raised both sides, raised by 2. -1 raised by 2, still +1. So we get 3 solutions. Yeah, this way may be better, because the other way, we have to think. Yeah, we have to think more. Okay, anyway, 3 solutions.